I want to take a deep dive on one of the problems for the homework we just had. Here I've got a parametric equation. My x-coordinate function is that x of t equals cosine of t plus twice the cosine of 2t. And then my y function, y of t, equals the sine of t plus twice the sine of 2t. And the problem asks us to find the equations for both tangent lines of this curve at the point where the curve intersects itself. So I've made a rough sketch here on my whiteboard that we can keep that in mind. But just to double check, here is what that picture would look like if I was using a graphing calculator to assist me. And what's nice about this is I can find the coordinates for this point where the curve intersects itself. Why? It looks like the curve intersects itself at the coordinates -2, 0. So I'll keep this in mind that the point that I care about has these coordinates. X is -2, y is 0. And if I think about it, that's already half of the information that I need to determine a tangent line. A tangent line requires a point on the graph of the function and the slope of that function. Except here, I'm not working with y equals a function of t. I'm working with a parametric curve. But I can still have this idea of a point on the curve and the idea of the slope of the curve is slightly more slippery here. But I can associate a number to this slope. All I have to do is I will calculate x prime of t, and I will calculate y prime of t. And when I divide y prime of t by x prime of t, that will be my slope at whatever t value I've got. So the equation for my tangent line would look like y minus the y value of the point I'm trying to hit. Well, that's 0 in this case. And this needs to be equal to the slope times x minus the x coordinate I'm trying to hit. So here that's going to be -2. And just to clean things up a bit, let's remember that subtracting a negative number gives me a positive number. So all I really have to do is calculate this slope. Well, I'm going to need these two derivatives. Let's get those out of the way. So if my x function is defined in terms of cosines, x prime of t is going to be minus sine of t minus 4 sine of 2t. Let me make a little bit more room for that. There we are. And likewise, my y derivative, y prime of t, will be cosine of t plus 4 times cosine of 2t. And for both of these, I'm using chain rule along the way to calculate these derivatives. Well, if I know what number t lands me on this point, well, which two numbers t land me on that point? I've got two different slopes that I'm looking for after all, then I'll have enough information to finish this problem. Although I might still have to do some work to find what number that is. So let me focus on this idea that I already know what my x and y coordinates are supposed to be. X is supposed to be -2, y is supposed to be 0. So how can I make sine of t plus 2 sine of 2t equal to 0? I have an easier time making a function equal to 0 than making it equal to any other number. Well, I've got these trig functions. And what I can do to make this a little bit easier on myself is to say, well, what's going wrong? What's giving me trouble here? I have the sine function applied to some angle measure, t. And then I have the sine function applied to a different angle measure, 2 times t. Well, that's a little bit difficult, a little bit slippery to be working with 2 different angle measures. So what I can do is I can use the double angle formula, that sine of 2t is the same as computing 2 times the sine of t times the cosine of t. So let me use that here. So 0 will be equal to sine of t plus 2 times sine times cosine. Looks like I've got 4 sine of t times cosine of t, like so. And I'm going to go ahead and factor this to say I've got sine of t times 1 plus 4 cosine of t, like that. This is why I said it's easier to know when a function is equal to 0. Now that I have a product, the only way this can happen is if either sine of t equals 0 or 1 plus 4 cosine of t equals 0. Those are my only 2 options. Now, I know which values of t make the sine function equal to 0. Those are 0 and pi. And any number of times around the circle, those will be other solutions here. But I really only care about solutions between 0 and 2 pi. Those are my 2 points. Now, I can test both of these numbers in my x of t function. When I do that, unfortunately, I do not get -2. X of 0 here is going to be +3. X of pi here is going to be +1. So I didn't quite do it. That means that I have to, the only way this equation makes sense, the only way my y coordinate can be 0, must be stored in this equation right here. It must be the case that 1 plus 4 cosine of t equals 0, or maybe a little bit more usefully, cosine of t equals -1/4. Okay, well, all I need to do is figure out what values of t make the cosine of t equal to -1/4. But -1/4 isn't any of those nice numbers on the unit circle that I have committed to memory. So what am I going to do here? T must be the number either I have the arc cosine of -1/4, or I have t equals minus that number, because the cosine function doesn't care if you have a positive input or a negative input. It can't tell the difference. It's even as a function. Now I can test these, but I already know from my algebra that plugging these numbers in for y gets me 0. And if cosine of t does equal -1/4, then I can check that my x of t function does give me -2 as desired. Now, how am I going to use this? It's a little bit awkward in terms of an angle measure. But remember, all I have to do is I need to evaluate this quotient. I kept it up here at the top of my whiteboard. This is the thing that I really want, this slope. And so I'm going to do my best to calculate this. So I think I'm fair to get rid of this diagram. Let me calculate the slope for this number t equals the arc cosine of -1/4. And then I'll come back and do the other one of these numbers next. So I need to take these two different derivative functions and evaluate them for this particular value of t. How do I find y prime of t? Well, that's just cosine of t plus 4 times cosine of 2t. Well, I already know that for this particular value of t, t is the arc cosine of -1/4, so that cosine had better be -1/4. That is exactly what the inverse trig functions are designed to do. They make calculating the cosine and sine function very simple. But now, what am I going to do for this 4 times cosine of 2t? I'm not immediately sure what I'm going to do with that. So, how did I handle this problem of dealing with twice an angle before? I used the double angle formula. So it looks like I will need the double angle formula for the cosine function as well. Cosine of 2t is equal to the cosine squared of t minus the sine of t squared, or the sine squared of t. However you like to say the name of that function. So I don't actually have question marks here. I know exactly what goes in that spot. So what is it? That -1/4 stays the same. Now I'm going to add on 4 times, well, cosine of t here is -1/4. So I must have the number +1/16. Okay, that's looking good. Now I have to calculate what is sine squared of t. Let's think about it. Cosine squared plus sine squared are always equal to 1. What is the number plus this fraction that makes 1? This must be the number 15 divided by 16. Which is also kind of saying, we'll hold on to this idea for a little bit, that sine of this number t is going to be the square root of 15 divided by 4. Or maybe minus the square root of 15 divided by 4. I know that Sometimes the sine function is positive, sometimes the sine function is negative, but these are really the only two values that it could take for this particular value of t. Well, I still have some algebra to work at here. If I take -1/4, sure, that's fine. And I'm supposed to add to this. Well, if I've got 1/16 and I take 15/16 away from it, really I've got -14 on 16. But multiplying by 4 will change that denominator. So, oh, funny that. It looks like I've got -15 on 16 for the value of my derivative, for my y derivative. Okay. We are halfway there. Oh, except for, excuse me, I was talking but not thinking about what I was typing. Those denominators should be 4s, and you probably already caught that. Let's keep going. Now I need to know, is the sine function positive or negative for this value of t? I know from my work before, x prime of t, this is minus sine of t minus 4 times sine of 2t. I know how to handle sine of 2t though, so really this is -8 sine of t times cosine of t. Okay. Now, what I'm going to do is I'm going to consult the unit circle. So I will need to make a little bit of room here in my scratch work. Let's grab all these things and just move them up a little bit. Now, on the unit circle, the x and y coordinates of points belonging to a circle of radius 1 spell out exactly the values of the sine function and the cosine function. I am using a value of my angle, my t, for which my cosine of t is -1/4. Cosine is measured by the x variable in the situation, so this is the vertical line x equals -1/4. And I do see that there are two different numbers, two different points on the circle. Now, it's nice to see that I have two different y values. One is the negative of the other. That matches up with my calculation from before. Now, how do I get to these? If I take a positive angle this way, that would get me to cosine equals -1/4. Sine would equal, looks like a positive y value. That would give me my sine equals positive the square root of 15/4. If I went the other direction, I would be going in the negative direction. So this would be some negative value of t. And that would give me my negative sine value. So let me check. So when I calculate arc cosine of -1/4, I in fact get a positive angle measure. So it must be that I've got the positive square root for my sine function. Now let's be careful here because I have minus signs in this formula. So I will, in fact, have minus the square root of 15 on 4, minus 8 times the square root of 15 on 4 times minus a quarter. Just by knowing what those sine and cosine numbers will be. So this is my way of getting around having to know exactly what this arc cosine number is. Because arc cosine is the inverse cosine, I automatically know what every single cosine in my formula will be equal to. And then once I know what value cosine has, there's only ever 2 values that sine could have. Once you pick it, there's only 2 options left. Now let me clean up this formula a little bit more. I've got some square roots in here, so I know everything. I can factor out a square root of 15. I'm just writing these letters because I can't type a radical sign on my whiteboard here. Then I've got minus a quarter minus negative 8 on 16. Well, minus negative 8 on 16 would be the same as plus 1/2. So this must be the number square root of 15 on 2. How about I freehand that one? So x prime of t equals negative root 15, all divided by 2. Now I know what number my y prime is. Now I know what number my x prime is. What I will do is I will divide them one by the other to get my slope. And that is the only thing missing from my tangent line equation. So let us make some more room here. I need to save this arc cosine value. I'll come back to that in just 1 second here. So as it turns out, for this problem, we will do this division. A negative by a negative gives me a positive. And in fact, after cancellation, I've got the square root of 15 divided by 2 as my slope. So that tells me x plus 2 here. And yeah, I'll go ahead and freehand that radical sign. This is square root of 15 all on 2. There we go. There's a tangent line. Just to double check, let us graph this tangent line. Show me the line y equals the square root of 15, that's my slope, times x plus 2. Oh, there it is in green. So yeah, that looks like a tangent line to me. Now, what could that other slope be? As long as I'm here, I think I'll skip ahead to what the answer is. So in purple, I'll have a very similar formula, only I'll make this negative. Now, why should it be negative? Oh, excuse me, I should be following my notes here. I don't actually need this 2, as you might have noticed on the Desmos. Sorry about that. So why should it just be minus the slope for the other one of these? The other t value that I've got is this one right here, where I've multiplied by -1. And I'm looking at t equals minus the arc cosine of -1/4. Well, when I look to my derivatives here, the y prime of t is all about cosine of t plus 4 cosine of 2t. And neither of those cosine functions can tell the difference between positive values and negative values. I'll get exactly the same thing. But when it comes to my x prime of t, x prime is all built up out of sine functions. Maybe a little bit easier to see up here at the top. If I put a negative into the sine function, then I can just factor that negative out because the sine function is odd, right? Sine of minus t is the same thing as minus sine of t. So when I make this calculation, I won't get negative square root of 15 on 2 here. I'll get positive square root of 15 on 2. So all of my algebra will look the same, except I'm down a minus sign. That's the reason why the other tangent line will have this formula. Y equals minus the square root of 15 times x plus 2. So there is my calculation. It takes a little bit of trig for this problem, but ultimately the thing that I want to be focusing on is this idea here, that for parametric curves, I still have slopes, but now, because I'm not constrained to functions, y equals f of x, now I can have multiple different tangent lines at the same coordinate. And the reason this all works out here is because these two different tangent lines correspond to the first time around the curve and then the second time around the curve. You can kind of trace it with your finger here. The first time moving around, I'm following this purple tangent line when I get close, and then I take a trip around the curve. My second time coming back, now I'm following the green tangent line. So there it is.